All right, 9.4, we're going to be talking about ellipses. They're going to seem very, very complicated compared to circles. That's just because this picture that we've got on the right looks very, very crazy complicated. Of course, in the book, it is a beautifully colored diagram that I copy and pasted, and of course is not color for you guys because that would be expensive. So instead of giving the book definition of an ellipse, what I'm going to do is basically just run you through and explain what on earth all these crazy things over on this diagram on the right mean. So the book does have a definition of an ellipse. It defines it as the set of all points in a plane such that the sum of the distances from the foci is constant. Okay, so these two, we've got a point right here and a point right here. They're labeled as F. These are both, this is a focus and this is a focus. So actually, first of all, I don't like to say that word very much. The plural of focus is foci or maybe foci, and I've heard it both ways and it confuses me and I don't like to sound unintelligent, so I don't know which way to say it. So we've got, you know what, maybe we say focuses. I don't know. So there's these 2 points, and basically what happens is if you're on any point on the graph, like this point right here, say you took this distance and added them together. Then you moved over here to this point, and then you took this distance and added them together. The numbers that you'd get for those distances would be the same. That's what an ellipse is. So you can move these 2 points anywhere you want, and the ellipse is going to get, wider or taller, or it could look a lot like a circle. They're basically ovals with a lot of complicated features. Okay, so I'm gonna, like I said, I'm gonna write out what on earth all of these pieces over here are. So they still have a center. We've got a nice little center here. These ones are centered right at the origin, but of course the center can move. We've got this, this right here is one of the foci or focuses, or however grammatically correct we want to be. There are 2 of them. It's the same points over here. They've got them labeled with F. And then each ellipse has 2 axes of symmetry. So we've got the major axis right here and right here, which is the longer of the 2. So you've got these 2 axes of symmetry. And remember, what symmetry means is you could fold them in half and they'd be exactly the same. So you've got the major axis, which is the longer of the 2. And then you've got the minor axis, which hopefully intuitively is the shorter of the 2. So major, minor, longer, shorter. So here, this one, we consider this one to be horizontal because it's longer in the horizontal direction, and we consider this ellipse to be vertical because it's longer in the vertical direction. Okay, so let's say that this one is centered at the origin. I also want to label on the vertices and the co vertices. So the vertices, that's the plural for vertex. We've got a lot of weird plurals happening here. So here, notice that the major axis goes this way. So the vertex here and here, those are basically the endpoints of the ellipse in that direction. Okay, so the vertices are A. So A is our variable. They are A units from the center. Okay, so notice right here. So here's 0, 0. Here's 0A, because you went A units up. Here's 0, negative A, because you go A units down. This right here. Here's the major axis. Notice you go A units to the left, so that's negative A, 0, or A units to the right. So the distance from this point to this point is our variable A, and so that's how you find the vertices. You also have the co vertices, and those mark the end of the minor axis. So this right here is the minor axis. The co vertices are on the end of that. So notice this is B units. If this is 0, 0, I go B units to the right. I go B units to the left. If this is 0, 0, I go B units up or B units down, and you can see that labeled right here. So the co vertices are B units from the center. Okay, the vertices lie on the major axis, and the co-vertices line on the minor axis. Okay, so lots of formulas, but again, just like I told you yesterday, do not panic. You have a note card. Okay, so here, these ones that we're starting with, these ones are centered at the origin. Just like yesterday, if you just have an x squared and just have a y squared, it's centered at the origin. Okay, so now this one right here, This one is horizontal. If you notice here, a squared is attached to the x squared. Remember, a goes with the major axis. And if the major axis goes with x, then it's longer horizontally, and that's what makes it horizontal, which is exactly what makes this one vertical. Here, a, the major axis, is associated with y. That means you're longer in the y direction, which is what makes this one vertical. Okay? Now the foci, or focuses, or whatever, they're labeled right on here. So on this horizontal one, you go c units. So now c is a different distance altogether. That's from the center to the focus. So your foci, we've got plus or minus c and then 0. So two different points, negative c0, positive c0. And then the vertical, we go up and down, so it's the y value that changes. So the x coordinate is 0. The y coordinate is either positive or negative c. Okay, the length of the major axis. You've got a units right here, and then another a units right here. So that would be 2a units. Same thing on the vertical, same measurement there. And then the length of the minor axis, you've got b units right here and another b units right here. So that would be 2b units. Same thing here. Okay, so that's what we've got so far. Lots of crazy things happening here. Last thing that I want to write on here is that the values of A, B, and C are all related. So like here's A, here's B, here's C. If you notice this right here, okay, so A, B, and C, because this is a different thing. A is also the distance from the co vertices to the foci. There's a lot of complicated things. I'm going to break down for you what exactly you should know and what is less important. Here, I want you to notice that this makes a right triangle. And the right triangle that it makes, you can use a squared plus b squared equals c squared, except unfortunately all the variables get mixed up. So if you look at this, you have c squared plus b squared equals a squared, because of course the way they have it labeled, why wouldn't they complicate it? The way they have it labeled, a is the hypotenuse, not c. So if you're trying to solve for c, it actually becomes c squared equals, and then you'd subtract the b squared over. They're all related like that. Okay, so that's one thing to keep in mind. The values of A, B, and C are all related. So we will probably end up using this equation to relate the major axis to the minor axis to the distance to the foci. Okay, like I said, it seems crazy complicated right now. Let's see if we can't break it down while we're looking at some of these equations. Okay? So we've got some different information right here. So an ellipse with these are the vertices, and then these are the foci. So we are centered at the origin based on these points right here. We haven't moved ourselves to be centered anywhere else. So if we're talking about, we want A and B eventually. So let me write down. Here, if our vertices are negative 4, 0, and then positive 4, 0, that means you're going this way. All right, so this must be your major axis because here the y-coordinate is 0. Here, the x-coordinate is 0. So that means it must be, and we'll draw these things here. You know, let's give it a little sketch. That might help us. So here's negative 4. 1, 2, 3, 4, and then 1, 2, 3, 4. So these are the vertices, and then these are the foci. So this is focus right here. This is a focus right here, and then these are the vertices. So we're going to look something like this. All right, we know we're centered at the origin, and then I labeled the focus right here and right here with an F. Okay, so this distance right here, remember that is our A. Okay, so that's a unit of 4, so we know A. We know A right now is 4. And then this distance right here is C. Okay, and then the last important thing we know is that these are tied together with this very important equation, which is just a slight tweak of the Pythagorean theorem. So we know that 2 squared equals 4 squared minus b squared. Okay, so what I'm going to do is I'm going to add the b squared to both sides, and I'm going to subtract the 2 squared from both sides. Okay, so these cancel. I have b squared equals 4 squared, which is 16, minus 2 squared, which is 4. So 16 minus 4 gives me 12. Okay, I don't actually need to find b, because if we remember from the fronts, b actually ends up being squared. So let's look at these formulas right here. So we have x squared, and then since my ellipse is horizontal, I put the larger value under the x squared. So here a is 4, so that means a squared would be 16. Let me write my formula here just so I know what I'm referencing. Okay, and then plus y squared over, and I just found out that b squared was 12. Okay, so that is my formula. Okay, so once you get down to it, once you get used to it, they're not that bad. There's just a lot of variables and a lot of formulas that we're dealing with here. Okay, so let's take a look at this. The graph of an ellipse can be translated. What that means is that we move the center. Okay, so these ones, we've got a new center, and if you look, this is a typo that I made. These are in fact the exact same equation. I did not mean for them to be the exact same equation. So what I want you to do is I want you to switch these up. Okay, so change this, make this y minus k squared, make this x minus h squared. I'm very sorry about that. Okay, so that's what your numerators should look like. That way they're opposite of these ones, just like we had on the front. So here, remember a squared is the larger of the two distances. If the larger is attached to the x, that makes it horizontal. If the larger is attached to the y, that makes it vertical. Okay, now the foci, here's what happens here. I have a new center. My new center is at HK. So let's make ourselves a little note there. My new center is at HK. So what happened, my old foci were at plus or minus C and then 0. I'm moving it. I'm like starting with a new center instead of 0, 0. So I'm adding these 2 points together. So what happens is I start at my new value of the center, then I add or subtract C, and then instead of 0, I move up to the new y value of the center. So that's where you can find my foci. We're not going to do a lot of work with this, but it's good to know, and it's a formula that you'll be able to write down. Here, same thing. I start at the value of h comma k, which is my center, and then I tack on what the old foci were, and it's this formula right here. Okay, so I'm basically doing the same thing. So I used to have values of 0, but I moved my center, so now those values are h. And then I used to have values of plus or minus c, but I start at k, so now it's k plus or minus c. So you don't have to memorize these. I'll show you how to kind of put it into use when we're doing examples. Vertices, very similar. Instead of starting at 0, 0, I'm now starting at hk. And then remember, if I was horizontal, my vertices were moving me a units to the left and a units to the right. So I'd have plus or minus a, and then not going up or down at all. So I start at h, I can move up or down a units, and then my center has moved to k. Now this one, if I'm vertical, remember for my vertices I'm going up and down. So I'm starting at the center, I'm not moving left or right, but I can move up or down a units. So h and 0 means I'm still at h, but then I start at k and I can go up or down a units. Okay, lots of crazy formulas. Just one more for you. The Co Vertices. Remember how much you go up or down on a horizontal? That's B. And then if you have the vertical ones like this, whoops, B is how far you go either left or right. So it's the opposite of what you're doing with the regular vertices. So here you're starting at your center of HK. The vertices are to the left or right, which means the co-vertices are going to be up or down. So I'm not moving left or right to get to my co-vertices, but I can move up or down B units. So this becomes H, and then my value of K can move up or down B units. And then here vertical, now I'm going left or right, so I start at my center of HK instead of starting at 0, 0. I'm moving left or right B units, and I'm not moving up or down at all. So this becomes H plus or minus B, and then K. So one last time, these are not formulas to memorize. You'll have them in front of you on your note card, and it's more important that we know how to use the formulas, okay? So example 2, let's look at our vertices. Let's look at our co-vertices. First of all, what I want you to be able to do is look at this information right here and instantly pick out if it's horizontal or vertical. So notice this. Here, 8 stays the same. So look at the vertices. Here, K stays the same. Look at the co-vertices. 3 stays the same. Here, the X value stays the same. That makes this horizontal. Okay, so what that means is we're going to be using this formula right here, so I'm just going to make sure it's on the screen so we can access it. So if you look at the vertices, this is H plus or minus A, and then this is K. So I know that this is my value of K. Okay, so K is 8. So we're using these formulas that you'll already have in front of you to kind of deduce some of this information. Okay, same thing here. The 3's are the same. That means H is 3. And then these values right here, this is supposed to be H plus or minus A. So H is 3. If 3 plus or minus A gives me -3 and 9, I'm starting at 3 and going up A units or down A units. Here, if you put 3 right in the middle, I'm going either up 6 units or down 6 units. So that means that A must be 6. And I can do basically the same thing right here. So look at my co-vertices. Co-vertices, I use this formula. K I know is 8. So 8 plus or minus B gives me 12 or 4. So 8 plus what gives me 12, and 8 minus what gives me 4, and that would be 4. 8 plus 4 is 12, 8 minus 4 is 4. So that means B is 4. Okay, so I have 1, 2, 3, 4 very important values that I'm just going to pop right into this formula right here, and I will have my ellipse. So X minus H, which is 3, squared over A squared, 6 squared, which is 36, plus Y minus K, which is 8, squared over B squared, B is 4, 4 squared is 16, equals 1. And that is how you find your equation. All right, so like I said, once you have those formulas in front of you, and you will, they will never leave your side unless you want them to, you will be able to do these pretty quickly and easily. Okay, more practice. This one, okay, Pluto's greatest distance. This is kind of a weird story problem. Pluto's greatest distance from the sun, or aphelion, whatever that is 4.583 billion miles. And its closest distance, or periphelion, is about 2.757 billion miles. Okay, so basically what they just handed us, if you look at the sun, we're going to consider the sun to be the origin. Okay, so they say at the origin. So the sun equals the origin, 0, 0. So that means I don't have a fancy H or a fancy K. I'm just centered at the origin. Let's look back at some of these pictures. Okay, so back at the picture, if we're centered at the origin, the greatest distance is A. That's what I've written here. The greatest distance is A. The shortest distance is B. Okay, so I want you to label that on here. The greatest distance. So that's your value of A. The closest distance, this value right here, is B. Okay, let's look at that picture one more time. If you look at this center, there is no closer point than this point. Everything else gets farther away until you're the farthest away, and then they start to get closer again until you're close, and then farther away, closer. So B, that's as close as you can get. And A right here is as far as you can get. I know the A is labeled right here. This picture makes it very confusing. C actually only goes from here to here. A goes all the way to this point right here. So this whole distance is actually A. So this picture is a little confusing. I don't love it. So we've got A and B. If you look back at this example, if the greatest distance is A, it says determine an equation relating the orbit around the sun. And so it really doesn't matter what we use as X and Y necessarily, so we could just kind of pick. So let's say that X would be this distance right here, and then closest distance would be Y. That kind of makes sense in terms of orbit, because the distance would normally be, you know, horizontal, the greatest distance, and then when it orbits around, then it would kind of be Y, like a vertical distance that would be like this. So we have X squared. There's no X minus anything because it's centered at the origin. And then A squared plus Y squared over B squared equals 1. And then what we're going to want to do is square those. It's kind of sloppy to just leave it like that. no functioning calculators. Let's try this one. So we just want to plug those values in and then get them to work. So even just a scratch pad would be just fine for this. So we want to take 4.583 and square it, and we also want to take 2.757 and square it. Okay, so let's just, we can just do 2 decimal places, would be totally fine. So this, we get 21.00 would be totally fine. So let's just do 21. So x squared divided by 21, and then plus y squared divided by, that was about 7.6. Okay, so that would be our equation. So coming up with equations, like I said, as long as you have all those formulas in front of you, you can figure out what A is, you can figure out what B is, and then kind of bring everything together, okay? So let's look at this last example. We did something really similar to this when we were dealing with equations. You see this crazy, this is called standard form for conic sections. We're going to do that completing the square thing again. Okay, so just like we did before, what we're going to do is we're going to group up all the x stuff. So we have an x squared and we have a minus 2x. We're going to keep those as their own little group. And then we have a 4y squared and a 24y. We're going to keep those as their own little group. And then I have this plus 21. I'm going to boot it to the other side with subtraction. So we'll have a negative 21 on the right. So very similar to what we did yesterday. So let's walk through this. X squared minus 2x. Remember, we take the center number, we cut it in half and square it. So half of negative 2 is negative 1. If I square it, I get 1. Now moving on to the y, this is different from what we saw yesterday because of this. With completing the square, you're not allowed to have anything in front, so what we're actually going to do is we're going to factor it out. So divide 4y squared by 4 and we get just a y squared. Divide 24y by 4 and we have a 6y. Okay, so if you redistributed that 4, I promise you'd land right back here, but we're not allowed to have a 4 out front. So now inside the parentheses, let's complete the square. So y squared plus 6y, take this 6, cut it in half, square it. Half of 6 is 3. 3 squared is 9. Close off the parentheses, we're done there. I have a negative 21 on the right. So let's talk about the illegal things that we just did right here. I added a 1 right here, so I have to balance it by adding a 1 right here. Be very careful with this. People mess this up over and over again. I did not add a 9. I added a 9 inside a set of parentheses. What I actually added was 4 times 9. If I were to redistribute that, this would be 4y squared plus 24y plus 36. So it's not a 9 that I used to balance, it's a 36. Be very careful there. Okay, so let's clean up a little bit. This right here, I get an x minus 1 squared. What multiplies to 1 and adds to negative 2? That would be negative 1 and negative 1. Here I have a 4 out front, don't forget about that. What multiplies to 9 and adds to 6? That would be 3 and 3. So I can write y plus 3 squared equals negative 21 plus 1 is negative 20 plus 36 is 16. Very last thing I'm going to do. If you flash back to your equations that we have right here, notice this right-hand side is just a 1. In my ellipse formula, I have to have a 1 there, not any other number. So whatever other number is there, I'm just going to divide by that number. We're going to do it on both sides. Okay, so that's my last little thing before I graph. So I have x minus 1 squared, and I divide that by 16, plus, and then the 4 over 16 reduces down to 1 over 4. So I have a 4 in the denominator, and then this is just 1. So this is my brand new equation. Okay, I am going to use that to graph. So let me show you what this is going to look like. So my center, let's start there. Center, I do the same way I did with circles. I take the opposite of this number, the opposite of this number. So positive 1, negative 3. It's always the opposite of what you see. So let's start there. So there is my center. Now this, from that point, 16, that's your a squared. So that means that a is 4. So from this point, I'm going to go in a horizontal direction, because a is horizontal. I'm going to go in a horizontal direction 4 units. So I'm going to go 4 units right there, and I'm going to go back 4 units. So 1, 2, 3, 4, and we'll leave a point right there. Okay, so these are my vertices right here. Vertices right there. Then this, that's my b squared, because that's the shorter of the two. B squared is 4. So that means B is 2. So in the y direction, I'm going to go 2 units both ways. So I'm going to go up 2, and I'm also going to go down 2. Okay, so that's my ellipse. Now these, I have a little more forgiveness with these because they're supposed to be lopsided. So I actually draw a pretty good ellipse. So that's our ellipse. We want to come up with a couple more things, make sure we answer everything. We've got the center. We'll come up with the foci in just a second. The lengths of the major and minor axes. Okay, so based on this, if this distance is 4, all the way across would be 8, because you have 4 here and another 4 here. So the major axis is 8. The minor axis would be twice this. So here's 2 and then another 2. So that would be 4. Okay, last one would be the foci. So we're going to use that relationship. The c squared equals a squared minus b squared. So 16 minus 4, and that's 12. So that's my c squared. So this is actually, these are very, very weird. What I'm going to do is my foci are in this direction. So I start at my center. And my center is HK. So H is 1, and then I'm going this many units left and right. So this tells me that C is the square root of 12. So C squared is 12, square root of 12. Let's flip back just because I feel like I'm talking about these formulas and you can't even see them. If you look at this right here, I'm using my center and then I'm going plus or minus C and then K. All right, so if you look at this, the x coordinate of the center is 1, and then I'm going up root 12, my y coordinate is -3, and then I start at 1 and I go to the left root 12. And then my y coordinate is -3. Like I said before, we're not going to do a ton of work with either focus because I think that the vertices and the co-vertices are more important, but this is the crazy way that you would find those. All right, so they'd be somewhere like here and here. We're not even really going to focus on graphing them either because this is an ugly decimal. All right, I apologize for the long video. We are going to spend a day and a half doing this, so that'll kind of spread out the material a little bit. All right.